What is date today? 24, no?
Yes, sir. 24.
New topic, beta. Circular motion. Circular motion. Okay. Seriously. All circular motions are rotatory, beta, but all rotatory motions are not circular. Okay. Every
Yes,
body
sir.
which is a circular motion are compulsory a rotatory, but all rotating body need not be a circular motion. Okay, na? So that is the first point
Yes,
you
sir.
need to remember. All circular motions, all circular motions are rotatory, but all rotatory motion,
Not sir.
all rotatory motion are not circular, or not circular. Okay, na?
Yes.
In circular motion, beta, in your circular motion, this is very important for rotational mechanics, but the toughest topic of the first year mechanics is your rotation. So be a little bit careful with the basics related to the circular motion, beta. In circular motion, length of the radius is always remaining constant, beta. Length of radius is constant. Okay, so that is one of the peculiar property. Whereas in rotatory motion, length of radius may or may not be constant. It may be a constant or it may not change. That depend upon the given conditions particulation. So for your rotatory motion, length of radius may or may not change. It may change or it may not change. Okay, na?
Yes, sir.
Whereas in circular motion, length of radius is always constant. Rotatory motion la length of the radius may be constant or it may be a changing part of it.
Change. Yes.
Example for this one is Earth revolving around the Earth. Sorry, Sun. Earth revolving around the Sun. Sometimes the radius will decrease, sometimes the radius will be increasing, circular path. Because you know that if this is a Sun right now, and this is your Earth, the path of that one is right now what in elliptical path.
Yes, sir.
So the Earth is revolving around the Sun in an elliptical path. Something like this. In this one, and like say if this is your Sun here, if this is your Sun, and this one is, say for example, your Earth. Okay, now see the distance between them. Here it is larger. When the Earth comes to this one, this will be your smaller. So radius
Yes, sir.
sometimes, even though it is moving in a circular path, so this is right now what a form of what a circular path in which the radius is not constant. If length is not constant, will it be a circular path, beta?
No, sir. It will be a
It
left.
should be what? A rotatory path.
Rotatory. Yes.
So in circular motion, length of your radius is constant. So obviously it is not a circular path, but it is a rotatory motion.
Path. Yes.
Okay, no? So there is a point you need to remember in this one. This one is point number 4. The line which is passing through the point of your rotation, and the point now, if I drop a perpendicular, that will represent me the axis. Okay, now, like say
Yes.
if I draw a like this, and it is revolving around this one, so angular velocity of this one is omega. So the given condition is right now, the line joining the line passing, sorry, the line passing through point of rotation, through your point of rotation, through point of rotation and perpendicular to plane, and perpendicular to the plane of rotation, perpendicular to the plane of rotation is called axis of rotation, is called what?
Axis.
Axis of rotation. This is very important bit. So what do you mean by axis of rotation, beta? Axis of rotation is nothing but what? The line which is been passing through the point of rotation and it is perpendicular to the plane of rotation. Now see this one, isn't it? This is perpendicular to the rotation, making an angle of 90 degrees. Okay, na?
Yes,
So
sir.
this perpendicular line, which is being perpendicular to the line, this line which is passing through the center of the axis, center of the rotation, and perpendicular to the plane of the motion is called as of your axis of your rotation. So the line passing through the point of rotation and perpendicular to the plane of rotation, perpendicular to the plane of rotation is called as of your axis of rotation. Okay, now,
Yes, sir.
every point which is being present on axis of rotation is must be at your rest. Okay, now, that means if I am standing on this axis, that is always in the rotating I body pen నిలబడ్డాం అనుకో, that will always be at rest condition only కదా.
Yes, sir.
So I can write here one point. Every point, every point on axis of rotation, every point on axis of rotation must be at rest, must be at your rest. Okay, and
Yes.
axis of rotation may be inside or outside the body. It need not every time inside, beta. So I can write here axis of rotation, axis of rotation may be inside, may be inside or outside.
Means like, what does that mean, sir? Inside or outside the way?
చూడు ఇప్పుడు let's say for example for earth, this axis is outside కదా,
Yes, sir.
but for the sun it is passing through the center,
It's in. Yes, sir.
isn't it? So that axis which has been passing through the center for one body and it may be your outside for the other body.
Okay,
See,
okay.
earth is
Means
revolving
outside
around its
means
own
not in its
axis.
orbit, sir.
Yeah,
Not in
so it is,
its axis.
yeah, it is revolving around its own axis and also it is revolving around the sun.
Yes, sir. Got it, sir.
So that is a given condition. So axis of rotation may be inside or outside the body. So these are some basic relations which you need to remember for the conceptual questions to be done. We have a lot of theory questions in the circular motion beta. This topic is compulsory from your material. You try to complete the conceptual questions that you give with clarity or depth of the topic basically. Okay, na?
Yes.
Next one is kinematics of circular motion. Kinematics of circular motion. Kinematics of your circular motion. మిడ్ టర్మ్ ఎగ్జామ్స్ ఉన్నాయి మీకు ఏమైనా ఇప్పుడు?
ఏం చెప్పలేదు సార్.
ఫస్ట్ వన్ బేటా, angular displacement. First one is angular displacement. గుర్తుందా? ఇది మనం చేసినట్టుంది, చేయలేదా?
డిస్ప్లేస్మెంట్ చేయలేదు సార్.
చూడు, కాలేజీలో కూడా చేయలేదా? సేమ్ లైక్ kinematics. Kinematics లో డిస్టెన్స్ ఆ డిస్ప్లేస్మెంట్ ఎలా క్యాలిక్యులేట్ చేస్తాం మనం? ఇన్ స్ట్రేట్ లైన్ కదా,
Yes, sir.
అవునా కదా? దీంట్లో వీఆర్ యూజింగ్ ది యాంగిల్. ఇఫ్ ఎనీ పార్టికల్ ఈస్ మూవింగ్ ఇన్ ఏ సర్క్యులర్ పాత్ లైక్ దిస్, yeah, this is your circular path, and this is your radius. This one is your point, and you are going from point A to your point B, and this one is angle made by this one. So this small angle, whatever you are taking, this is called angular displacement. Which is the
Yes, sir. కానీ మనం
angular
చేయలేదు సార్.
displacement? Angle covered by radius vector. O to A is a radius vector, that is nothing but r. O to B is also a radius vector, that is nothing but of your r. So A to B is nothing but what beta? Distance I traveled here right now. A to B is nothing but right now I can write this one as of your arc length. This one is your arc length. Okay, I'm representing that arc length like say for example S.
Yes, sir.
Okay, na? So now how do you define an arc length beta?
Theta by 360 into pi r.
This arc length will be equal to how much?
Sir, is that the correct formula only, sir? What I see.
Trigonometry మనం చేసుకుంటావు కదా, ఐడియా ఉందా?
Yes, sir. Theta by 360 into pi r square.
That is angle కదా.
Okay, that's finding the angle. Yes. Length is
Converting radians you are telling right now for me. Angular displacement is nothing but what right now for me? Angle described by the radius vector at the center of the circle. Okay, I'll write the definition C for this one. So we'll get the relation. Okay, yeah. It is the angle. It is the angle made by radius vector. Made by radius vector at center of circle. At the center of your circle. Okay, like say at A is equals at A, you are at T is equals to 0 at your A. You have been traveling in a time T is equals to T second. You have reached to a point of your B. Okay, for you're going from your A to B particulation. So time interval for this one will be equal to how much beta? Delta T is equals to T2 minus of your T1. So arc length is nothing but what beta? AB kada. So arc length is equals to your AB, that is equals to your radius vector r into your theta.
theta. Yes.
So this one is yes is equals to your r into your theta. Clear?
Yes, sir.
Isn't it? So for the given condition, if I'm writing the relation right now for me, so S is equals to r into theta, or theta is equals to, how to write the relation right now? See here,
Yes,
theta is equals to your arc length divided by radius vector.
radius. Yes.
Divided by your radius vector. Okay, so this is your theta, and the unit of this one, arc length is divided by your radius. It is measured in your radians. It is measured in your radians. Angle made by that one is nothing but what beta for me? Radians part of relation. Okay, na? So that is
Yes.
a basic terminologies which you need to remember for the given condition. So theta is equals to arc length by your radius vector part of relation. Theta is equals to arc by your radius vector part of relation. Okay, na? So unit is nothing but what?
Radians.
Theta is nothing but of your in terms of your radians part of your relation. Okay, na? Chalo. Next one is angular velocity. Next one is angular velocity. Angular velocity exactly similar to the kinematics velocity beta. So where it is represented by omega bar, vector quantity kabatti. It is displacement theta.
Yes,
and
sir.
here it is velocity. And how do you write the velocity in kinematics beta? Velocity is equals to distance by time.
Yes, sir.
Velocity is equals to distance by time. Ila rashama manamu v is equals to dx by dt.
Yes,
Rx
sir.
by t. Unit is nothing but meter per second. Avuna kada?
Yes,
So the
sir.
same thing right now here. angular velocity in the place of x, we'll be writing theta. So angular velocity in the place of v, I'm writing it as of your omega. So it is nothing but the ratio of, or you can say that right now, the rate at which the body is been changing. That will be called as of your what beta? Angular velocity. Anything divided by time is called as of rate beta. Okay.
Okay, sir. Yes, sir. Yes, sir.
Anything divided by time is called as of a rate. So
Great.
omega is equals to your d theta divided by your dt. That means the rate of change of angular displacement is called as of your angular velocity. Can I
Velocity.
write like that better? The
Yes,
rate
sir.
of change of angular displacement. I can write here right now. See, the rate of change of angular displacement. The rate of change of your angular displacement is called angular velocity, is called angular velocity. Okay na, represented by letter omega, represented by letter omega part of
Omega.
relation. Okay na, got an idea,
Yes, sir.
isn't it? Can you tell me the units for this one? Can you tell me the units for this one? Theta is measured in
Theta. Radians.
radians, time is measured in
Seconds, sir.
seconds, so unit is
Radians per second.
radians per second. Vichinda?
Yes, sir.
So that is about your angular velocity part of relation. I hope you got the conditions right now there.
Yes, sir.
Isn't it? So angular displacement is nothing but equal to right now for me what? Angle made by the radius vector. Angular velocity is nothing but the rate of change of angular displacement is called as angular velocity. Unit is radians per second.
Radians per
Unit
second.
is radians per second. Small angular displacements are vectors beta and large angular vectors are your scalars. You need to remember that one here. So I'll write with your star mark here 1 point. Small, this one is in bracket also. Small angular displacement, small angular displacements or what? Vectors. Okay. Large
Large
angular
scalars.
displacement, large angular
Scalars.
displacements, large angular displacements are what? Scalars. Okay, na?
Yes, sir.
Theta is measured in degrees and radians beta. Theta is measured in degrees and radians. So keep a note here right now. Theta is measured, theta is measured in
Degrees and radians.
degrees and radians, or radians you can say, or radians. Okay, and it is an axial vector beta. Theta can also be written as a what vector? Axial vector. That means it depends upon the axis. Okay, axial vector
Yes,
means
sir.
what? Depends
Depends
on,
upon.
depends on axis of rotation. Depends upon your axis of your rotation. Okay, na? Good. If it is 180 degrees, it will be how many radians beta? 5 radians.
Yes, sir.
Avuna kada? So 180 degrees is equal to 5 radians. 360 degrees is
2 pi
equals to
radians.
2 pi radians. 90 degrees is equals to 90
Pi
degrees
by
is
2
equals to
radians.
pi by 2 radians. Pi by 2 radians. 60 degrees is equals to pi by 3 radians.
Yes.
Pi by 3 radians. 45 degrees is equals to pi by 4 radians. Pi by 4 radians. 30 degrees will be equal to pi by 6 radians. ఇది టక్కర్ ఇట్లా గుర్తుపెట్టుకోవాలి నాన్న.
Yes, sir.
Isn't it? Because in coming chapter, this will be using this one a lot basically. So you need to remember this one as it is for the given conditions, isn't it? So this was
Yes.
about your north part. And omega is what beta? Delta t by theta. So if you are writing with the differentiation, it is known as of your instantaneous beta. It is known as
Okay,
what?
sir. Yes, sir.
INST.
Instantaneous
Instantaneous
angular
angular velocity is
velocity.
d theta by dt. Okay, na?
Yes, sir.
Same way, children. One more point here. Average angular velocity. Average angular velocity. Average angular velocity. Average angular velocity ఎలా రాస్తాం నన్ను? Average is represented by your symbol something like this, with a
Okay,
vector.
sir.
Okay, so
Yes.
omega, kada. Okay, so average angular velocity is equals to your delta theta divided by delta t. That means this will become for me t2 minus t1 divided by your t2 minus of your t1. Okay, na?
Yes, sir.
So if I'm writing in terms of an average, it is theta 2 minus theta 1 divided by theta 2 minus theta 1. Unit is radians per second. Unit is radians per second part.
Second.
Instantaneous omega is equals to d theta by your dt. This is known as of your instantaneous, isn't it? So from this one, if I need to get an angle, what I can do, d theta is equals to, I can write this one as of your omega into dt and raskocha. Angular displacement కావాలనుకోండి dt ఇక్కడ తీసుకెళ్ళిపో. So integrate on both the side. Integral of d theta is equals to your integral of your omega into dt. Integral of d theta will be equal to how much beta? Theta కదా,
Yes, sir.
అంతే కదా, ఎందుకని integral of your
dx
dx
is
is always equals to your x. So
x. Yes,
integral
sir.
of d theta will be equal to how much for me? Theta. So integral of d theta is
Yes,
nothing but
sir.
theta. That is equals to integral of your omega into your dt. The limits for this one is t1 to your t2 అనుకుంది. Okay na?
Yes, sir.
So this is your basic formula in terms of your integration, and it is also be taken say that theta can also be calculated by area under omega t curve, okay na? This
Yes, sir.
because integral of y into dx will give me what beta? Integral of y into dx will always gives me what? Area. This is basic integration. Integration చెప్పాను నేను అది.
Yes,
Integral
sir.
of your omega into dt will always gives me what? Area. So if ఒకవేళ మనకు graph ఇచ్చాడు అనుకోండి, and if there is a graph between omega and t, that means area under that omega into t. If it is area of triangle, you take area of triangle. If it is area of trapezium, you take the area of trapezium, whatever it may be. So the area under omega t curve will always gives me what beta? Angular displacement will always gives me what? Angular displacement part of
Displacement.
relation. Is that clear?
Yes, sir.
We need to define some more terms in this one beta. Next one is time period. Next one is your time period, represented by letter capital T and measured in what beta? Seconds. Measured in your what? Seconds part of relation. Any particle which is moving in a circular path, something like this. Okay, this one is like now some here. This particle is moving from point A to your point B. It takes some time, gada. So it is moving with certain angular velocity. It is from here to here. It is moving with an angular velocity omega, and this is your angle theta, isn't it? So this omega will be equal to this omega. We can also be written as of your 2 pi by your capital T. Right? Omega is equal to theta. Anko. Theta is nothing but what? For one complete rotation, theta will become how much beta? 2 pi radians. Kada?
Yes, sir.
Time
360
will
degrees.
become how much for me? Capital T.
Yes, sir.
Isn't it? So I can write that one as omega is equals to your 2 pi by your capital T, 2 pi by your capital T. And reciprocal of the time period is called what beta? Frequency,
Yes, sir.
isn't it? So if I'm talking about your frequency represented by letter F. Frequency is nothing but what beta? Reciprocal, or I can say this one is nothing but of your number of revolutions. Number of revolutions per second. Number of revolutions per second. Okay, that means
Yes, sir.
F is equals to your 1 by T. Number of revolutions per second. That means 1 by T value will become how much beta? 1 by T value will become for me how much? Omega by 2 pi.
Yes, sir. Omega.
Isn't because
Yes.
1 by T is nothing but F kada. So 1 by T can be written as of what right now? Omega by your
Omega by
capital T
2.
and right?
Yes, sir.
Sorry, capital
2 pi, sir.
omega 2 pi. Sorry.
2
So
pi.
this one is
Omega by
your
2
2
pi.
pi. Yeah. That means omega will become how much beta? Omega will be equal to 2 pi into your frequency.
Yes, sir.
So 2 pi into your F part equation. So omega is also what type of a vector beta? Axial vector. Okay, omega is
Yes,
also what your axial vector. That means it depends upon what? Axis of your rotation, which depends upon your axis of your rotation. Is that clear?
yes,
చిన్న example చూద్దాం. We'll get much clarity about this one. చూడు, if omega is equals to 120 rotations per minute, rpm into rotations per minute, what is its value? What is its value? What is its value in radians per second beta? What is its value in radians per second? So how do you do this one? Omega is equals to it is 120 revolutions per minute. That means how many revolution? 2 pi divided per minute and divided by 60. So that will become for me radians per second. Ante kada, theta by time.
yes, sir.
Isn't it? Theta by time is nothing but what? Theta is to be taken in terms of 2 pi.
Great.
Time
Yes,
should
sir.
be taken in terms of your 60 seconds kada. So per
Yes,
minute అన్నాడు కాబట్టి 60 seconds. E0 వెళ్ళిపోతుంది. And then anything else? 6 ones are 6 twos are 12. So omega
4
will
pi
be equal to how much beta? 4 pi
4
radians per
per
second.
second.
అర్థమైందా?
Yes, sir.
ఈ కన్వర్షన్స్ చాలా ఇంపార్టెంట్. తర్వాత ఇబ్బంది పడతా చూడు, అందుకోసం చాలా డీటెయిల్ గా చెప్తున్నాను నేను బేసికల్ గా.
Okay, sir.
ఓకేనా?
Yes,
నెక్స్ట్ వన్
sir.
చూడు. ఇఫ్ ఒమేగా ఇస్ ఈక్వల్స్ టు 120 ఆర్పిఎస్ అంటే ఏంటి? రెవల్యూషన్ పర్
Per
సెకండ్.
second. Yes, sir.
సో ఒమేగా ఇస్ ఈక్వల్స్ టు హౌ మచ్ ఎట్ టైం ఇన్ రేడియన్స్ పర్ సెకండ్. ఇన్ రేడియన్స్ పర్ సెకండ్. అర్థమైందా? అంతే కదా. ఇది ఆర్పిఎస్ అంటే ఒమేగా ఇస్ ఈక్వల్స్ టు 2 పై ఇంటూ 120 రాసుకో ముందు. సో
120 into 2.
120 ఇంటూ రేడియన్స్ అన్నాడు కదా. రేడియన్స్ అంటే 2 పై డివైడెడ్
Yes,
బై
sir.
పర్ సెకండ్ అన్నాడు అంటే 1 సెకండే కదా.
Okay, yes.
Isn't it? So it is 2
Yes,
pi
sir.
into, that is 120 into 2. How much it is? 12 twos are.
240
Yeah, 240
240
pi radians
radians per
per
second.
second. Machinda.
Yes, sir.
So I hope you got an idea related to your. I think it is undergoing the time beta. In another 10 minutes it will stop. So you rejoin it once it is been completed. Okay, na?
Okay, sir. Yes, sir.
Chalo, fine. Let us try to do some problems based upon this one. These problems try chena. Find angular speeds. Find angular speeds of seconds, comma, minutes and hours hand in a clock. The circular motion hai kada.
Yes, sir. Because it's
Isn't it?
moving.
Yeah, it is moving in a circular path kabatti. Find angular speed antunnadu. So angular speed for the first one what beta? In seconds. Ante omega in your seconds will be equal to how much beta? 2 pi into 1 divided by your 60. Ante kada. Omega formula ఏమని చూడు. What is omega formula? Omega is equals to 2 pi by your capital T.
Yes, sir.
Isn't it? So angular, how many rotations it is making? Only one rotation kada.
Yes,
So it
sir.
is 2 pi into 1 divided by 60. Ante this will become for me 2 pi
Pi
by
by
over
30.
60. Ante that will become for me pi by 30. Unit is radians per second. Radians per second. Okay na?
Yes.
Omega for minutes. Omega for minutes. How many for one revolution? So it is 1 divided by, minute means 60 into 60.
Yes, sir.
So this will become for me 2 pi divided by 6 6 are 36, 3600. And it ఎంత అవుతుంది? Pi by, this will become for me how much?
1800.
1800 radians per
Per
second.
second.
వచ్చిందా?
Yes, sir.
Angular velocity or speed in hours hand. So that is equals to, hours hand will make one complete rotation kada dantla. So it is 2 pi into 1. In how many time, how much time it will make one complete rotation beta? Hours hand
12 hours, sir.
12 hours kada. So it is 12 into how many minutes? 3600.
60 to
అంతే కదా, 60 minutes
Yes,
into
sir.
60 seconds.
Yes,
So
sir.
that will become for me how much? This one is 2 ones, this one is 2 6. అంతేనా?
Yes, sir.
So that will become for me 1 by 36 into 6.
90. 36 into 6 is 6 is 36, 3 0 18. 2 1. So 21,000 something. 21,600.
కరెక్ట్ చెప్పు.
Yes, sir. Correct. 21,000.
ఎంత?
21,600.
21,600. ఇంతేనా?
Yes, sir.
యూనిట్ విల్ బి రేడియన్స్ పర్ సెకండ్. అయిపోయిందా?
Yes, sir.
So find the angular speed of seconds and minutes and hours and in a clock part of relation. Now if I am asking one more thing right now. So what is the ratio of omega of your hours and in a clock and angular velocity of self rotation of earth your earth. Okay, so now tell me what is omega of earth first. Earth will rotate its one complete rotation in how much time, beta? 24
365.
hours.
Okay,
Ah,
rotation, not
rotation
turn.
kada about its own, mana day
24.
and night.
Yes, sir. Yes, sir.
24.
24.
2 pi into one rotation about its own axis into 24 hours into
60
3060.
into 60. Yes, sir.
Yeah, isn't it? So this will be the relation for the omega. Now
Yes,
we
sir.
need the ratio of this one, and this will become for me how much? 2 ones are, this one
Ones
is
are
2
12,
12s are.
sir.
అంటే ఇక్కడ ఎంత ఉంది? 6. ఇది క్యాన్సల్ అయిపోతుంది కాబట్టి ఇఫ్ ఐఎమ్ టేకింగ్ ద రేషియో ఒమేగా ఆఫ్ యువర్ అవర్స్ అండ్ డివైడెడ్ బై ఒమేగా ఆఫ్ యువర్ ఎర్త్, రెండింటిని డివైడ్ చేసాం అనుకో 1/360 1/360 గెట్స్ క్యాన్సిల్, 6 1s 6 2s, అంటే దట్ విల్ బికమ్ ఫర్ మీ 2/1. అంతే కదా?
Ella, sir.
అవర్స్ అండ్ ఇది వేసుకుంటే ఇది కిందికి వస్తుంది, ఇది పైకి
Yes,
వెళ్ళిపోతుంది
sir.
కదా.
Yes, sir.
So that will become
Yes,
for
sir.
me what this condition. So ratio of that means angular velocity of your hours and is equals to 2 times the angular velocity of your earth. Antena?
Yes, sir.
So this is also important relations you need to remember for your competitive examinations. Clear?
Yes, sir.
You can just rejoin beta once. Okay. I'm ending the meeting. You just rejoin it once. Okay. Na?
Yes, sir.